So, for this, so what's 1 squared? 1, yep. 2 squared? 3 squared? Okay, 4 squared? 5 squared? 6 squared? 7 squared? 49. 8 squared? 9 squared? And then 10 squared? 100. So, during this lesson, a lot of people will ask, like, are you going to give us these numbers on the test? No, because I just taught you how to find them. Okay, so if you just square all the numbers, then you'll be able to come up with this list on your own when you need it. Okay, so we are simplifying radicals today, so it's kind of like the equivalent of reducing a fraction, but for square roots. Okay, so your objective is students will be able to simplify radicals so that the radicand, which is the stuff underneath the square root, contains no perfect squares other than 1. And when it says perfect squares, it's like these are your perfect square numbers, the numbers that you can take the square root of, okay? So we're going to be just working on like just simplifying radicals to like lowest terms. And the way that you will know if your problem is like ready to stop and like you can give your final answer is that these 3 bullet points have to be true. So the first one, the radicand has no perfect square factors other than 1, which is what we're doing today. The radicand contains no fractions. We'll do that another day. No radicals appear in the denominator of a fraction. That's another day. Okay, so we're just going to only focus on this first one. And then this like little note of how to do this is going to apply to the shortcut way that I'm going to show you how to do, which is the way I do it. But I'm going to show you guys the way that, like, if you have friends in other classes, like other teachers, the way that they will be doing it on their homework, so you can recognize it. It's longer for sure, but it's like a good way to kind of like understand it, and it's like a good thing to fall back on. Okay, so I'll show you like the way that everyone's learning it, and then I'll teach you the shortcut way. So what you're basically doing is you're trying to take this radical and you're trying to pull out any numbers that you can take the square root of that exist underneath this, okay? So a little note before we start, in order to take something, like remove a square root from something, you have to have a group of 2. Because what is the square root of 9? 3. Because how many 3's are in 9? Yep, a group of 2, right? 3 times 3 equals 9. So you take that group of 2 3's, and then it can get rid of the radical to get your answer of 3, okay? So just remember that you have to have a group of 2 in order for it to not have a radical anymore, okay? So when we're doing this, we're going to do the long way first. It's called like the birthday cake method. So we're basically going to be creating a birthday cake. Do you guys remember doing like prime factorization, like factor trees? Okay, do we know what prime numbers are? Okay, so prime numbers are numbers that are only divisible by themselves in 1. So 1, but we're not going to use that. So 2, 3, 5, 7, 11, 13. But we're pretty much only going to use 2, 3, 5, and 7. Maybe every once in a while it'll go higher, but that's pretty much all you'll need. So you're going to do your bottom layer of your birthday cake. And you put that number there. And you're basically going to continuously divide by prime numbers until you reach the birthday candle, which is 1, okay? Start with 2. If it's divisible by 2, use that. If not, try 3, 5, so on. So is 8 divisible by 2? Yeah, so when I divide by 2, what am I going to get? 4. And you just kind of keep doing that. So is 4 divisible by 2? Yep. So if I divide that again by 2, I'm going to get what? 2. And then is 2 divisible by 2? Yes, so it's 2 divided by 2. 1, which is your birthday candle. Okay? So what you're going to do is you're going to set yourself up a radical. And you're going to find groups of 2 of the same number. And for every group of 2, one of those is going to go on the outside of the radical. So how many groups of 2 do I have? One groups of 2. How many groups of 2 can I make? Just with these outside numbers, sorry. Just one, right? This is a group of 2. And then I have a leftover 2. Do y'all see that? So this group of 2 is going to allow 1 2 to go on the outside. And then I have 1 left over that doesn't have a group, so that's going to go on the inside. This is going to be confusing at first. Just roll with it. After we do a few, then it'll be fine. Okay? So that's going to be the simplified version of that. And I'm going to show you another way too that's faster once we do these. Okay? All right, so now let's do 54. Okay, is 54 divisible by 2? Yeah, what do you get? All right, is that divisible by 2? Nope, what about 3? Yep, okay, so what's that going to be? 9. Okay, 9 is divisible by 3 again, right? To make what? 3, and then 3 is divisible by 3 again, right? To make 1, which is the candle. And whenever you're doing groups of 2, it has to be the same number, okay? So do your radical. Okay, so what do I have a group of 2 of? 3. So that's going to allow 1 3 to go on the outside. And then I have a 3 and a 2 left. So whatever you have, you're going to multiply together. So what's 3 times 2? 6. So that's going to go on the inside. Trying to get it? Okay. All right, and then 160, and then I'll show you the shortcut way. Okay, what's 160 divisible by? 2. And what's that going to be? 80. Okay, and then divide by 2 again, and what's that going to be? And then divide by 2 again. Divide by 2 again. And then divide by 2 again. And then I can't divide by 2, but I can divide by 5. And what's that going to be? If I divide by 5? 1. Yep. Okay, so how many groups of 2 do I have? Because I have 2 of those, so both of those are going to produce a single 2. So what's 2 times 2? 4, so that's going to be on the outside. And then for the inside, what's 5 times 2? 10. Yep. Any questions on that? Okay, so that's good to know to have to fall back on. Now I'm going to show you the way that I do this. If you would say that you're not very good at quick math facts, or you don't usually do math in your head, or if I say what's the square root of 16, you want to say 8 before you say 4, then you might not want to do the shortcut way. You might want to stick with this way, because this way will for sure give you the right answer. Okay. The shortcut way, basically what you're going to do is, let me get a color. So we have a square root of 8. You are going to break this down not using prime numbers, but using numbers that have square roots. So this list right here. Okay? So your goal is to find the biggest number on this list that goes into your number evenly. So you're going to start at the top of the list, start high, and then work your way down, because if you do too small of a number, then you have to keep going, and it's kind of annoying. Okay? So what's the biggest number on that list that goes into 8 evenly? So it has to divide into 8. 4, right? 4 is the biggest number that goes into 8 evenly. So 4 times what is 8? 4 times 2 is 8. And then just take the square root of the first one. What's the square root of 4? And you're done there. Okay, and then the next one, 54. And you're going to want to use a calculator for this to help you. So like what usually when you get in the habit of it is, so you know you have 54, so start like around 54 and just keep doing 54 divided by until you find one that works. Okay, if you can't immediately find it. So biggest number on the list that goes into 54, evenly. 9, right? 9 times what is 54? 9 times 6. And then what's the square root of 9? 3. So see, same answers. It's just quicker of a process, but this also like requires you to kind of like be quick with math, right? Okay, and then 160. And you'll start to kind of memorize what numbers work for what numbers. So use your calculator to help you. Do 160 divided by, start at the top and then work your way down. Once someone has it, let me know. 16, yeah. 16 times what? 16 times 10, yep. And then what's the square root of 16? 4. Does that make sense? Okay, something I want to talk about is if you were to have done 4, for example. So let's do that. So I'll just do like a little side note here, how to fix it. So if we did 4, so 4 times what is 160? 40. So you always want to get in the habit, if you're doing this method, of looking at this leftover number and seeing if there's still another one of those that goes into that. Because then you know that you didn't do a high enough number if that's the case. And you'll start to recognize there's only a certain amount of numbers that are like done numbers, like 2, 3, 5, 6, 7, 10, like ones that aren't divisible by any of those. Okay? So here, if you do accidentally do this, so what's the square root of 4? You don't have to start over. You can just keep breaking this one down. So then which of those numbers is the biggest that goes into 40? Anybody? On this list, biggest number on this list that goes into 40? 4. 4 times what? 10. Yep. And then what's the square root of 4? 2. So then these will multiply. So it's 2 times 2? 4, and then bring down the radical of 10. So it's longer, but you can still get to the answer if you don't use a big enough number. It's kind of like when you're reducing fractions. You know how sometimes most people will try to find the biggest number they're both divisible by, but then some people, they'll just like keep dividing by 2 over and over and over again until it's simplified. It's kind of like that. Okay. All right, so you guys can use either of the 2 methods, whichever one you want. Try these ones. Just keep in mind if you're using the second method, the first radical should always have the number from the list, okay? So that you can take the square root of it. Are we done? Yes, no? Yeah. Okay, so I'm going to do this way, but if you do the birthday cake way and you're not getting it right, then tell me and I'll do the work for that way, okay? All right, 12. So what number from that list is the biggest that goes into 12? 4. 4 times what? 4 times 3. And then what's the square root of 4? 2. So you should have 2 radical 3. Okay, what's the biggest number on the list that goes into 75? Yep, 25 times what? 3, and then the square root of 25. Yep, so 5 radical 3. And then what about 98? Yep, 49 times what? 2, and square root of 49? Yep, so 7 radical 2. Does that make sense? Any questions or anything before we move on? And again, this is crucial. Like, if you get good at doing this semester will be a lot easier for you. Because we're going to do this a lot. Okay? All right, cool. So now we are just going to add in numbers in front. So the only thing that changes here is that you're going to just kind of keep that number out front till the end, and it's going to multiply times whatever you end up with in the front. Okay? So let's break down 50. What's the biggest number on the list that goes into 50? Yep, 25 times 2. And then the square root of 25 is 5. And then you're just going to multiply these two numbers together. So it's 2 times 5. Yeah, so 10 radical 2. Okay, and then 300, what's the biggest number for 300? Yep, 100 times what? 3. And keep in mind, 100 isn't where it stops. Like, it'll keep going, but I just stopped there because most of ours, we're not going to need to go higher than that, okay? And then what's the square root of 100? 10. And then when you multiply, you should get 50 radical 3. Good? Okay, try the next ones. You'll start to quickly memorize, like, the numbers that you use for 24 on the list. So you use the first number has to be this. I think it's worth it. Make sure when you're doing this for your work, just so you don't make it later very radical around that, so that you can see that it gets removed when you take the square root. Yeah. No, not that big though. Just the 64, because then it goes away when you get to the 8. Because you take the square root of it. Here, then don't worry about the 4 in front. So don't multiply times that other 4. Here, so the first number has to be from this list. So if you're finding the biggest number that's on this list, that goes to 48. Yeah, exactly. It's easier to just like start around 48 and then just work your way down. And just keep dividing and checking. Okay, so for the first one, what's the biggest number that goes into 48? 16. 16 times what? 3. And then the square root of 16. So you should get 16 radical 3. All right. And then 128, what'd you guys use? 64 times 2, and then the square root of 64 is what? So you should have 24 radical 2. Good? Yeah? Okay. All right, so now we're going to add in variables. So the only thing to keep in mind with the variables is that you need groups of how many. When we were doing the birthday cake and all of that, we had to have groups of what to bring it out? How many had to be in a group? 2, right? So for every 2 x's inside, 1 x is going to get to go outside, basically. Okay? So when we have an even amount, then there's not really an issue, and then we'll do an odd amount after. But essentially what you're doing, since you have to have groups of 2 to pull them out, is you're going to be taking the exponent and just dividing it in half. Okay? So make your 2 radicals and pick what numbers you'd use for 147. I don't know. 49? 49 times what? 49 times 3. Okay, and then you're going to take the this part, the variable part, and if it's an even number for the exponent, you're going to put the whole thing in this first one and nothing in the second one. You will only ever have nothing in the second one or just a single variable, like an exponent of 1, never anything more than that, okay? So when you do the square root, what's the square root of 49? 7, and then you're going to cut the exponent in half. So x to the what? 3rd, yep. And the reason why is because we need groups of 2, right? So if I have x to the 6th, I have x times x times x times x times x times x. How many groups of 2 do I have there? 3, right? So that's why it's x to the 3rd when it comes outside. Because it's 3 groups of 2. Okay? So now 27x squared, what are we going to use for 27? Yep, 9 times 3. And then the whole x squared is going to go there. And then what's the square root of 9? 3. And then what's half of 2? Just 1, so it's just going to be 3x, and then radical 3. Okay, and then we have a number in front on that one. Same thing, though. Just leave it out front till the end. All right, 32, what am I going to use? $16, yep, 16 times 2. And then what's the square root of 16y to the 4th? 4y to the 2nd, yep. And then multiply that together, so 12y squared radical 2. A little side note, just so you guys are aware, the reason why we need groups of 2 is because a square root, what's that number that's like the little number here? A 2. So if that's, when we're doing cube roots then, and you're trying to simplify those, you need groups of 3 to be able to come out, okay? We're not going to do those this year. Only square roots. Okay, so you guys try those ones? what number from this list is the base one? No, so start at the top, so start kind of 545 and work way down. Not yet. So then, sorry, that way. Like the whole thing. Yep, okay, so now make the 2 square roots. Sorry, so you said 9 times 9 in that one, and then 9 times what is it? Just put 5 under that one. And then you're going to put the whole x to the 8 with that 9 in that one. Yep, and then we'll just work. And then bring down the radical 5. Yep, that's right. All right, so for 45, what's the biggest number that goes into 45? Yeah. So 9 times 5. Okay, so what's the square root of 9x to the 8th? Yeah, 3x to the 4th, radical 5. As far as like Math Excel goes, like inputting your answers, this is an exponent on the x. It's not a like part of the root. Okay. All right. 24. What's the biggest number? 4 times what? 6. Okay. And then 4x to the 10th turns to what? Yeah, 2x to the 5th. My blood ring keeps getting caught on my pants. Okay. Keep the 7 out front. So 200, what do you use? 100 times 2. All right, and then what does 100y to the 6th turn into? Yeah, 10y to the 3rd. And then when you multiply those together, you should have 70y to the 3rd radical 2. Okay, any questions? Cool. Okay, so the last thing is now just if you have an odd exponent instead of an even exponent, right? Because you can't really do half of an odd. So you just have to make one little adjustment. All right, 32x to the 5th. So figure out how we're going to break down 32. Yeah, 16 times 2. And then for the variable, since it's 5 and you can't do half of 5, you can't do groups of 2, you're going to put one of your x's in the second one, like the extra x that you have, and then put 4 of them in this one. So if you have an odd exponent, you're always going to have a single variable in the second one, never more than that, okay? So then what's the square root of 16x to the 4th?
4x.
Yeah, 4x squared, and then your 2x. Make sense? It's like kind of logical. Like. All right, this one, save the 3y. All right, 48, what do we use? Yep, 16 times 3. And then put a single y in the second one, and how many in the first one? Yep, 6. And then what's the square root of 16y to the 6th? Yeah, 4y to the 3rd. And don't forget, that's a 3y to the 1st power, right? So when I multiply those together, I'll get 12y to the 4th. Because you have to add the exponents. Good? Okay, go ahead and try these last two. All right, we ready? All right, 54, what'd you guys use? For 54? Yeah. 9 times what? 6, and then you shove n, and then n to the 6th. Shove 3, n to the 3rd, radical 6n. Good? Okay. What about 80? Yep, 16 times 5, m to the 8th. Okay, what's the square root of 16m to the 8th? Yeah, 4m to the 4th. And then that's going to be 8m to the 7th, radical 5m. Good? Any questions? Okay, good. All right, here's your lesson check. Yeah. Yeah. Okay, answers, please. All right, so for this one, you have 7 radical 2, 3x to the 6th radical 2, 4b squared radical b, Okay. There's your answers for those. Do you have any questions on those?
One.
Number 1. So you'll use 49 and 2.